In section 3.1, we're going to be talking about elements, compounds, and mixtures, and the different characteristics that define each one of these. We've talked a lot about elements, and we know that elements are listed on the periodic table. Each one of these boxes represents one element. Elements are pure substances. They're going to be made of only one type of atom. So, for example, the element gold is only made of gold atoms. Elements cannot be broken down. Elements are the pure substance that is the simplest form of that substance that exhibits its individual chemical properties. Elements are going to be made of atoms. Those are the individual particles that make up an element. So when we look at these images here, we have two different images that represent elements. And that's going to be having these singular atoms of only one color, so that represents one type of element. And then we also have diatomic molecules. So in this example of oxygen, we have two blue circles that are bonded together. We know they're chemically bonded together because they're touching one another in this image. So when we have these blue circles that are bonded together, that indicates that there is a diatomic molecule that's present. And if it's diatomic, that means that it's going to be classified as a singular element. There are several types of elements that are diatomic, and the easy way to remember that is the 7 rule. So if you find the 7th element, which is nitrogen, this starts our listing of diatomic elements. So if you make a 7, starting with element 7, we do like this in these purple boxes here, and that is going to indicate the location of the diatomic elements. So nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, those 6 elements are always going to be diatomic naturally, so they always travel with a buddy. And then our 7th one is over here, hydrogen. And hydrogen is always by its lonesome as number 1. When we have a compound, compounds are going to be made of elements. They're specifically made of 2 or more different elements that are chemically combined together. So they no longer retain their individual properties of what each of those individual elements represented, but when they chemically combine together, they react, and that's going to cause new properties to be exhibited. Compounds are also going to be considered pure substances since they're only made of elements. And one example of a compound that we're familiar with is H2O, water. So we have 2 hydrogen atoms and 1 oxygen atom. And when these are bonded together chemically, when they react to form water, they're going to take on the properties of water. So it no longer is going to exhibit the chemical properties of hydrogen or oxygen. They're going to exhibit the properties of water. And it has to be in this specific ratio. If it's in a different ratio of atoms, or if it uses different elements, then it's not going to be classified as water. It has to be H2O. Another example is salt, sodium chloride, NaCl. Sodium is a gray metal, and chlorine is a green gas. So when those combine together, it makes a white crystallized powder, which is salt. And that's something that we actually eat and we put on our food. So it no longer is going to exhibit the properties of sodium or chlorine. It's going to exhibit the properties of that compound, sodium chloride. So here in this image, we have the yellow circles we were looking at earlier for hydrogen or helium atoms. And in this example, we have oxygen molecules. So we have our diatomic oxygen molecule. So these 2 are both classified as elements because it's a singular type of atom. However, when we look at a compound, now we throw in a different type of element. So we had oxygen here, and those were 2 oxygens bonded together that were indicating that it was diatomic. And with this compound, we have 2 hydrogen atoms and 1 oxygen atom. And because we have 2 different elements present, that indicates that it's now showing us a compound. It's showing us a substance that has taken on different properties when it combined. Here's a few other examples of compounds. Ammonia, NH3. So we have our nitrogen and our 3 hydrogen atoms. So whenever we have those atoms bonded together in that specific ratio, that's going to make ammonia. And this one is showing us sulfuric acid. So for a compound, it has to be in a specific ratio to be that chemical substance, to be that specific compound. And because compounds have the materials, those elements bonded together chemically, they can only be separated chemically. So compounds can be separated, but it has to be through a chemical reaction occurring. Mixtures are not pure substances. So when you have a mixture, you basically take a bunch of things and you throw it in a bowl and you mix it up. So that's a mixture. Each of those items in the bowl, in that mixture, will retain its individual properties. So mixtures are just going to be physical combinations, substances that are in the same proximity, they're in the same area. And there are two different classifications of mixtures, heterogeneous and homogeneous. So you can use stems to help you break down these words to help differentiate between them. Hetero means different and homo means same. So when you have a heterogeneous mixture, you can see the different parts and you can really easily separate the different parts in a heterogeneous mixture as well. Chex Mix is a great example. So when you have a bowl of Chex Mix or trail mix, you're going to have pretzels and peanuts and some Chex pieces and maybe some Cheerios or Cheez-Its. You're going to have a lot of different materials dumped in the same bowl, mixed up. But what if you don't like the pretzels? Well, you can always pick out the pretzels. You can easily separate the different parts in a mixture, and you can manually separate those. You don't even have to use any kind of chemical procedure. You can separate those really easily because they are only physically combined. They're not bonded together. In a homogeneous mixture, the substance is going to look the same throughout. So all the particles are going to be uniformly distributed throughout it. Kool-Aid is a great example. So when you make Kool-Aid, you're going to take Kool-Aid powder and water or maybe some sugar. You're going to mix all those things up. You're going to stir it up. And if you haven't put too much sugar, then it should all look uniform throughout. If you put too much sugar, then it's going to settle down to the bottom and it's going to take on more of this molecular look. So if you have a homogeneous mixture, it's going to be uniformly distributed throughout, like the green circles and the purple circles here. If you have a heterogeneous mixture, it's going to be all chaotically mixed up. No kind of pattern, no kind of uniform distribution. There's also not a specific ratio of the materials that are involved in mixture. So if you are making Chex Mix and you want to put a lot of pretzels in there, then go right ahead because there's no specific way to make Chex Mix. So when you look at these examples, in this first picture, we have a mixture of two different compounds. And we know it's two different compounds because you have this one specific shape, and that is water molecule. And then when you have this other weird shape, and that's showing us sulfuric acid. So you have those two things, and they are present in the same area, and they are chemical combinations of these different elements that compose these particular types of compounds. And they're in the same box here, so it's indicating that it's a mixture of two different compounds. The second one is going to be a mixture of an element and a compound. So we have our compound NH3 or ammonia that we were looking at, and then we also have these black circles, which indicates an element. So it's repeating this black circle, so we know that image is standing for an element. And then in this example, we have a mixture of two different diatomic molecules. So these are considered a mixture of two different elements. So we know that it's diatomic because we have the same atom, the same colored circle that's bonded together. And we have these white circles and we have these blue circles. So that indicates that there being those two different colors, that there are two different elements that are present. So let's look at these examples. So we have our diatomic hydrogen here. So this is showing us diatomic element being present. So it's classified as an element. In this example, we have our water molecule. So we have yellow circles bonded to this big blue circle. So that indicates that we have a compound since it's the only item that is present in this substance. This is showing us a mixture of two different elements, two different diatomic molecules. So we have whatever this blue circle is, that's one element, and whatever the yellow circle is, which is a second element. So we can assume based on these images that we've previously looked at that the yellow circles that are bonded together here are showing us H2, which is hydrogen, and the blue circles are showing us O2, which is our diatomic oxygen. And in this last example, this is showing us more of a heterogeneous mixture because you have a lot more of our H2, you have a lot more of these yellow circles present than you have the blue circle. So these are both the same. They're both mixtures. They are mixtures of two different elements, but this second one is showing us that there are more yellow circles present. So there are it's more of a heterogeneous display. So let's wrap this all up. Matter can be separated into pure substances and impure, not pure substances. So when we have pure substances, that's going to be an element or a compound. Elements are going to be represented by singular image of just one repeating item or one repeating color. And when we have a compound, it's going to be represented by two or more different elements, two or more different colors or different shapes that are present, because the compounds are going to take on new chemical properties. They no longer retain the individual chemical properties of the elements that make up the compound. And then our impure substances are going to be mixtures. So mixtures are going to be classified as homogeneous or heterogeneous. And if it's homogeneous, it's going to be more uniformly mixed throughout in no specific ratio. So compound is going to be in a specific ratio, homogeneous mixture is not, but it's going to be pretty uniformly distributed. And then a heterogeneous mixture is going to be chaotically mixed together. So you're not going to have any kind of uniform distribution, and a lot of times you have some of the material that actually settles out at the bottom.